Welcome to this e-lecture on data management. At the end of this lecture, I want you to have an understanding on the importance of data management for research and to understand where the problems in data quality can come from, as well as some simple solutions to try and get around these. I'll then ask you to create a state-to-do file all focused around data management. So, what is data management? This is just the process of controlling the information generated during a research project. All research will require some form of data management, whether you're doing a literature review, a trial, an observational study, or whether you're working with qualitative or quantitative data. You will always have some form of data in your project. In fact, most funding agencies and ethical review committees will require a data management plan before they give approval. It's really important to think this through at all stages of a research process, from the acquisition of data to the processing to the storage. It can be the most time-consuming part of research. So, why do we care about this so much? Well, the quality of the answer to a study depends on the quality of the information collected in the study. So, the answer to your research question comes from the analysis, which is based on the data. And if you have rubbish data going in, you're going to have rubbish results coming out. Messy, inconsistent, or contradictory data will mean that the analysis will have the same problems. Because of the amount of work that goes into planning, collecting, analyzing, and disseminating research, it's a real shame if the study results are called into question because you have issues in the data management. Confidence in data quality is important to successfully reach a study conclusion that is reliable and valid. So, let's take the standard structure of a research project and talk through some of the data management decisions that you might want to think through at all these stages. Let's start with the hypothesis and planning stage, where you're really thinking about what variables to collect and how best to collect them. Let's take a simple example. Let's take the variable of age. There are several ways that you can collect age. For example, you could ask someone a date of birth, but you'd also need to ask the date of the interview or the date that you've asked that question in order to calculate their age. Or, depending on the units that you're asking for someone's age, you might get different answers. So look at the table below. This is real data from a study conducted in Malawi, where two different groups of people were collecting age from the same group of children, but using two different forms, one where age was specified in months and one where age was specified in years. And you can see that there's not perfect overlap. This might be because the data was collected differently or incorrectly by one group of data collectors versus another, or it might be that there is some overlap in these categories which isn't apparent. For example, if a mother says that their child is 2 years old, does that mean that the child is 23 months old, 24 months old, or even 25 or 26 months old? In this case, you're going to have discrepancies between the two types of data. Next, data collection and entry. Is the data collected accurately and are you storing it safely? And what are the ways that you can try and encourage robust and reliable data at this point in a study? So, let's talk about the field side first. What we mean by the field is when you go out to collect information from a participant. There are several challenges in this, including keeping your forms, or if you're collecting data on a tablet, keeping them safe and tidy, and having a filing system in place. Next is knowing who you've interviewed and who you still need to interview, and how are you sampling those people? Are you collecting information from the right people? How have you found them? And have they understood the questions in the way that they're meant to be understood? And finally, making errors when recording the information. This is relatively common, that when you are collecting data from someone in a questionnaire, you might accidentally tick the wrong box or write down the wrong thing. So how do you deal with these? There's several solutions, from simple checklists, making sure that there's a filing system, ensuring that any training of data collectors includes specific instructions on data management, including ethics and consent taking, noting any issues on questionnaires so that when they come back to the office, you can see that there's a challenge in that questionnaire and the reason why, and ensuring that there is regular communication and feedback with the people collecting the data someone that's cleaning or entering the data, and the person analyzing the data. Next, you have data entry at the office. Some of the challenges in this is knowing which forms have been entered onto a database and which haven't. If your data is being collected on paper questionnaires, you quite often need to enter this into a database such as REDCap or Microsoft Access. So you need a proper filing and archiving system to know which forms have and haven't been entered to prevent duplicates. Then you might have information that doesn't make sense or is inconsistent. You can have inbuilt data cleaning rules within databases to try and deal with this. For example, not being able to write a date of birth that's in the future. There's also an issue of making errors when entering forms. Again, this is relatively common. Most studies will have a data entry error rate of between 1 and 6%. That means you need a way for checking for these. For example, making sure that you have checklists for missing forms or numbering each form with a unique number to make sure that you can find it again to check it when it's been archived. And again, making sure that there's regular feedback and communication with the field team. So then you come on to data validation and cleaning. So this is where you've got your data set in the correct format that you want for analysis, but you need to check it to make sure that it's correct and valid. So this is a process to see whether the data are inaccurate, incomplete, or unreasonable, and working out ways to try and correct it as much as can be done. So let's start with data validation in the field. There are ways to try and make sure that the data is clean and accurate before it comes back to the office. For example, directly supervising interviews, where you can make sure that all interviewers or data collectors are collecting the same information for each question. That's to make sure that your data is internally consistent. Next, you can have field callbacks, where you can send the data back into the field to double check with the respondent that their answer was correct. Both of these are relatively resource intensive. So other approaches could be to take videos or photos. For example, if you're collecting the vaccination status of a child and transcribing that onto a paper data collection form, you could also take a photograph of the vaccination record and check one against the other when you're back in the office. This is also done for GPS spot checks. So if you're recording a location in a data collection form, you could also take a GPS point if you're using, for example, a tablet, to make sure that the data is coming from the area that you think it is. In the office, you should then have some form of pre-entry checks, so making sure that the data makes sense before it goes into the database. Again, checking the number of forms that have come in versus the number of forms that you think should be coming in and those that you've sent out. Doing checks on key information, such as ID information or key demographics. So for example, checking that you don't have any records of men being pregnant. This would be checking key information and demographics, or making sure that the ages are accurate. So if you're collecting data on women of childbearing age, making sure that that's biologically plausible. The main one is making sure that if you're using unique study IDs, that they are genuinely unique. If you have duplicates in terms of your study ID, you need to clean these to make sure that you have an accurate numerator and denominator for your analysis. A common way of doing this cleaning is to use do files. These are Stata files where you record a series of commands using pre-specified rules and checks that you've decided as a study team to then generate a list of records that you think might have issues in them. You can then use these lists to go back to the original data and check and see whether this was a data entry problem or whether this is a larger issue that might need to go back to the field for checking. At this point, you can record your data cleaning decisions in the do files and keep an archive of these to make sure that it's really clear what you did to the data. You then come on to the analysis stage. So by this point, you should have a dataset that seems clean. But are you getting suspicious numbers or values? Are the associations that you're seeing a bit strange and not what you're expecting? What about missing data? How are you going to deal with that in your analysis? So the key at the start of any analysis is to check everything again. So you have your raw data, which has been sorted and arranged, and now you're trying to present it visually or in a model. Quite often at this stage, you might want to recode the data, so making continuous variables into categorical variables and making sure that there's no extreme outliers. You also need to make sure that you make a data dictionary and that this is clear and can be accessed by somebody not part of the study. A data dictionary is essentially a file that includes all the variable names as well as where they came from, what they mean, and any codes. So for example, if you have gender recorded as 0 and 1, you need to record somewhere what 0 means and what 1 means. Another really key thing is to make sure that you document all your decisions. You need to document, for example, how you're going to deal with missing data, what you decided to do with records that had issues that could not be cleaned. Do you exclude them from the analysis? Or do you use something like multiple imputation to try and correct any missing values? All of these decisions need to be justified and made clear so that you can defend your results and your analysis when you come to disseminate. Which brings us on to our final step, which is the write-up and dissemination of your research results. At this point, you need to make decisions about whether the data is being shared, and if so, how. I've included here a good example just to highlight why this is so important and why it's required from many funding and ethical agencies to make your data available at the end of a study. The authors in this paper accessed a dataset which had a trial published previously showing a positive association between the use of these antidepressants and a reduction in depression in adolescents. However, they had some questions about the analysis that the original authors did and decided to access the raw data and conduct a new analysis. And in fact, they found the complete opposite association. So, this brings us on to the ethics around what you do after the study ends. Most ethics committees and funders will require study data to be archived for a minimum of 6 years at the end of a trial. Whilst the requirements for observational studies aren't as rigorous, it's still best practice to ensure that you have an archive policy in place. Sweden, in fact, has quite a strict archiving policy, so it's well worth being aware of this before you start a study here. Increasingly as well, both funders and journals will ask for open access data. This means that at the end of your study, you should be aiming to put your raw data in an anonymized format into a data repository so that other researchers can access the data and conduct their own analyses. So it's really important that you have a clear data management plan going from the hypothesis stage all the way to the end of the study and beyond. So I hope those have made some of the principles of data management clear. I'm going to ask you now to do an exercise using Stata for data management. However, this isn't the only software that's appropriate for this step of a study. You can also use things like Access or REDCap, or if you're using NVivo for qualitative research. But one word of caution, Microsoft Excel is not the best software to use for data management. So it's worth your time learning how to use Stata or one of the other softwares I've mentioned. Thank you for listening and good luck with the exercise.